Welcome, everyone. I'm so glad you could join us for tonight's Tech Topics. We are joined today by another familiar tech topic friend here, Andre. He's going to be telling us all about computer-aided design, or CAD. It's a word you might have heard before when it comes to graphics and design and prototyping, maybe. And he's going to give us the information on what it is and kind of how to get started and how it's used. Andre, thank you so much for joining us today.
It's no problem. It's what we're here for. All right.
All right, folks. Andre's going to take it away, and I'm going to pop off camera. Remember, if you have any questions as we go along, type those into the chat box, and we will answer them during the Q&A.
All right. So to get started, like we said, we're going over computer-aided design today. Kind of a very broad term as far as, I don't know, any kind of specific software goes, but that vagueness is kind of, it's a very key thing as we get into it. But yeah, this program will go over what it is, how does it work, how is it used, and what features to kind of look for when you're looking for software. What is computer-aided design? So computer-aided design is kind of software that typically uses these special graphics called vector graphics to draw very precise and scalable lines. We'll kind of get into what those specifics are later in the program. But what you need to know is that the precision and scalability of these graphics are used to communicate like mechanical and technical designs. So think like drawing blueprints, creating animations with 3D models, stuff like that. These vector graphics are then used to help render 2D and 3D objects. This kind of depends on what type of software you're using and what the specifications for that software is. It can be limited by hardware limitations or just kind of what the software is intended for. Kind of have to look into that, and we'll get into that later also. And commonly, they're typically saved in file formats that include SVG, .obj, and .stl. If you're used to 3D printing or laser cutting or anything like that, these might look familiar. They use a lot of the same mathematical precision that we need to use when developing 2D or 3D models. So from there, how do they work? So depending on the software, you're going to have different ways of kind of creating your 3D designs or 2D designs, any kind of graphical or topological thing. It's going to kind of depend on what software you're using. Might sound confusing, but what it really kind of boils down to is how you approach the design. Some will require you to enter in very specific data so that you can create a figure using your keyboard and mouse or like a stylus. You might have some more flexibility that way. Comparatively, other software will have you using like primitives, which are basically like predefined shapes and solids, stuff like cubes, cylinders, cones. You kind of stack those on top of each other to create your design from there. However, getting back to vector graphics, to visualize this, CAD uses vector graphics. These are very, very specific and precise mathematically generated equations that help draw very, very precise lines over a Cartesian plane. Some of you guys might have heard this or heard of what a Cartesian plane is back in math, back in high school. Basically, it's that X and Y axis with the negative X, negative Y, positive Y. Basically, when you're drawing with vector graphics, the computer handles all like the precision of mathematics that it takes to actually plot a point or to draw a line on this Cartesian plane. And that's very, very good for anything that really needs precision. Once again, these are used for mechanical and technical drawings or 3D models. So you kind of need that precision when you're describing or kind of visualizing something for somebody else. Yeah, so, and because of these vector graphics, because they're so precise and they don't use like pixels or anything like that, it's just literally like a solidly drawn line by a computer. They can be scaled pretty well without, or rather, they can be drawn bigger or smaller without loss of definition. We call that specifically scalability. We'll get into more of that a little bit later, but what you really need to know is that most of these software rely on vector graphics to produce very precise drawings Kind of depends on what software you're using, how you're entering in that vector graphic. But besides from that, the vector graphic itself relies on scalability. You can blow it up as large as you want. You can shrink it down as large as you want, but it's still going to hold that definition. It's still going to convey that same kind of information that you need mechanically and technically. Right. So a variety of software and variety of software and uses. CAD, like I said, is a very broad and kind of vague term, but it's often used in a lot of industries. Video game asset production, CGI, prototyping of machinery, architectural and engineering drawings. Anything that kind of just relies on precision on drawing, you're going to use it in CAD, or you're going to use CAD for it. Likewise, they might be very specialized depending on what industry you're working in, but the actual how to use it should be pretty familiar. You're just plotting stuff. You're using vectors to draw what you need. You're using this precision to communicate something very specific, visuals, concepts, stuff like that. So down at the bottom here, we have 3 different specific CAD software. They all belong kind of in different sectors of industry. This first one here is Blender, the orange and blue kind of, I guess, eyeball. Blender is used predominantly in the video game and asset production industry, along with CGI. It's a very strong software. I should also mention that all 3 of these have free options that you can just download for free. They're all freeware. Tinkercad itself is more of like a web-based tool, but you can use it on your own browser, free of charge. Blender itself is video game and CGI production. You can use it to render very specific physics, lighting, stuff like that. We'll get in a little more specifics about that later, but it's used in the industry for very, very, very niche video game asset production and CGI. Tinkercad is a little more leisurely. You can use it as a child, kind of just experimenting with 3D figures. This is one of these software that I mentioned previously that uses primitives to describe shapes. You would use like cubes and rectangular prisms, cylinders, cones, spheres to kind of just build what you need, carve out what you need, and kind of create a object from there. You can kind of do some prototyping in there, although it might not be up to snuff compared to something else like AutoCAD or SketchUp, which is this third one here. SketchUp is predominantly used in like the architectural and engineering field. It's particularly useful in kind of creating like diagrams for buildings, diagrams for furniture, stuff that you might need multiple like views from. It's really useful for kind of just conveying that like lived in kind of graphical design. I'll take a sip right here. All right, so uses and applications. These are kind of 2 examples of what CAD can be used for. Used in prototyping and design prior to fabrication. Obviously, these are 2 different types of CAD images. One's 2D and the other's 3D. The 2D image kind of gives you a lot of information very quickly. At a glance, you can see the top profile, the side profile, and a cross-section of it. If we really wanted to, we can even label specifics of it, which it does right here with a key. You could even give measurements if you needed to. This would be very, very specific to like machining and prototyping and having specifics of how a specific part in a machine would fit into the rest of the machine kind of thing. Comparably, this 3D model right here, which is also a CAD image, it is a camshaft with a bunch of pistons kind of rotating around it. This kind of conveys different information. You can kind of see how it would look in real life, what individual parts of it is. If we wanted to, we can animate it and you can see the pistons running up and down. So key features to look out for. Some CAD software is very specific. Like I mentioned, it's very industry focused. So if you're intending to do something with it, make sure that the software matches the job. You should make sure that the software employs vectors for scalability. We mentioned this previously. Vectors are very, very precise mathematical equations that are used to kind of convey a shape or design. The difference in between designing only in 2D or 3D can make a difference in specific software choices. So like, say you were trying to use Tinkercad and you were trying to use SketchUp comparably. SketchUp, you'll probably get away with way more design flexibility compared to Tinkercad, where you only have the shapes to kind of design with. Um, just keep that in mind. All right. Making sure software employs vectors for scalability. Yeah, that precision and scalability kind of helps with resolution, as you can see with this image over to the right. Without vectors, your graphics may look a little muddy comparatively. That's the difference between a raster and a vector graphic. Rasters are basically what we would use in like photography, general graphic design like Photoshop. Um, it's very pixel based. So when you blow it up, it's going to look pixelated. It's going to have different spots of varying colors. And that's very good for like a very natural gradient at a distance kind of thing. But when it comes to vectors, if you scale up and down, it's going to kind of not leave a very good graphical design. Um, Vectors, on the other hand, are very crisp. Because of this, you can blow up a 3D model and without losing resolution. You can throw up a 2D version of the same drawing without losing resolution, as pictured here. And finally, if you're looking at CAD software, there's kind of different paradigms on how you can edit a model. Uh, some of them are listed here. They include freeform modeling, explicit and dynamic modeling, and procedural parametric modeling. Some examples of these: freeform modeling would be more specific to like some aspects of Blender. Freeform, you can choose individual points and move them wherever you'd want to kind of give like a different impression on what the 3D object is. Procedural and parametric can also be handled by Blender. This would be more specific to designing a 3D model that has to endure specific physics for like a video game, or in CGI for like an animated film. Explicit and dynamic modeling is it's kind of a mix between the two. You can upload a model into like a procedural or parametric space so that it has rules applied to it, but you can kind of keep editing it without those rules applied, if that makes sense. It's kind of like a perfect balance between the two. Another key feature to look for is rendering capabilities. So rendering is a very broad subject as well. As you can see, CAD throws a very wide net. So rendering is basically how does the software handle visualizing a object. This can also feature specifics on like textures. This can feature specifics on lighting, motion simulation, just a whole host of different features that you might be aware of if you play a lot of computer games, or if you're big into like, once again, CGI and film production. This stuff is very specific to that. Different software kind of handle it differently. Some software may be able to render in 3D, but when you want to take like an actual snapshot of what the object looks like in 2D, or just like as a render, it might just use a raster instead to kind of convey that information. So that's a lot of very key specific information that you should look into before purchasing software or downloading something, is just acknowledging that while more industries are kind of including rendering as part of the capabilities of their software, they all kind of have different capabilities based off of hardware limitations or just industry limitations. Once again, the stuff kind of handles realistic lighting with ray tracing, which is a very like CPU or GPU intensive process. Same thing with motion simulation with physics. It just kind of depends on what industry this specific software is intended for. So once again, we're looking at a list of different software that are used in the industry for CAD. Once again, Blender is used for video game and film industry productions. A lot of animation, a lot of light rendering, a lot of texture rendering, stuff like that can be handled in Blender. There's even like 2.5D kind of tools in there where like you can create kind of like a vectorized 2D plane and then stack them on top of each other so that you have something similar to parallax moving in animation. Once again, Tinkercad it's you can kind of use it as a prototyping tool, but it's more leisurely than you would want it to be. SketchUp is more for architecture and engineering design. Autodesk, once again, specific to architecture and engineering design. They do have specific software for individual fields. So like AutoCAD might be the specific one that you would use for actual architectural and engineering design, but Autodesk is just kind of the larger umbrella for it. And then LibreCAD is another open source software that's offered for free. It's more intended for everyone, I suppose. You can kind of just download it yourself. It's free. You can open up different files from like AutoCAD and stuff like that in it and just make edits. It's the open source alternative, basically. With all of these, you should be aware that there are some security concerns with them being free. Just make sure that your computer or software is able to handle it, or your computer or hardware is able to handle it. Likewise, you shouldn't be charged for most of these if that were the case. The only thing that you ever should be charged for when looking at these software is for like an individual upgrade for like a subscription-based model. Autodesk offers that, and I believe SketchUp does too. But otherwise, most of these are available for free online. You should be able to download at least a copy of them and tool from there. To get you guys started, if you guys are interested in finding out more about CAD, you can always visit hcplc.org/online classes. There we have a link to LinkedIn Learning. Depending on how you sign in, you might need this library ID at the bottom here, but otherwise you should be able to just use your library card and PIN to log in. Some of the offerings that they have are Prog Design, AutoCAD, Blender 3.3 Essential Training, SketchUp Pro. A really useful thing about LinkedIn Learning is that they use a lot of professionals to teach you guys these things. And so you kind of get an actual look into how these software are being used in their industries themselves, and, you know, get to learn the little tips and tools and know-how of the industry and how to use them. All right. And finally, continuing the experience, we have the Hive, where you can actually go to one of our specific libraries that has a larger makerspace. You might be able to actually use the recording studios, sewing machines and classes, 3D printing, desktop cutters. There's a whole host of things that you can do at any one of our Hives. If you wanted to use your CAD skills, you can use them to do 3D printing. You can use them to do laser cutting if you wanted to. But yeah, it's wherever you wanted to take that.
We even have information on some of our nicer Adobe capable computers there. So if you want to use the free version of Photoshop, the full suite, they have those as well at a lot of locations. The Hive site will also link you right to that. That stuff's expensive.
So make good use of it.
Right.
All right. And finally, we have our contact us page. If you guys need to contact us, you can reach us at hcplc.org/contact, or give us a call at 813-273-3652. All right.
I think we're ready for our Q&A. So if you have any questions as we went along that you are itching to ask about CAD and computer-aided design in general, or something specific that we covered today, go ahead and get that into the chat box for us as we go along. If you joined a little bit later and you think we might have covered something that you missed that you absolutely need to know, don't be shy. Let us know. We can pop back and review something really quick. We've got a little bit of time still, so definitely get those questions in for us. So, Andre, I have a couple of questions.
Mm-hmm.
When you're talking about rendering, I know that's okay. So CAD's a really, really broad term because CAD covers anything that's a computer making some sort of a graphic or a design that we're going to use for something, whether it's something to look at or something to 3D print or something to, cut out on our Cameo or Cricut. That's all computer-aided design. So that's a really broad term for a lot of very specific tools. And then we came to the term rendering, which also was a very broad term that could mean any number of different specific things. Do you know of any kind of cheat sheet or quick reference where if somebody's like trying to get started with computer aided design for like a very specific field or task, that they could kind of go to and like figure out, okay, I want to do this, and I know that rendering is the right word, but I don't know how to use it when it applies to this type of software. Do you know if there's any kind of like quick reference, any good way for them to get that narrowed down information other than coming to the branch and seeing us?
Uh, I mean, you may be able to Google a few of these things. Not that you would want to rely completely on Google, but I mean, depending on what the actual field is, a lot of these kind of do just cover very broad swaths of the industry. Like I mentioned, Blender just covers a lot.
Mm-hmm.
That's a lot of animation, a lot of just asset creation. Um, when it comes to specifics on rendering, such as very heavily intensive stuff, Blender would probably be the way to go. I'm not too sure if there's a lot of other 3D modeling programs that you would use outside of Blender for like that kind of industry. When it comes to like architectural engineering, stuff like that, AutoCAD is usually the go-to. So is SketchUp. Both of those are very good at rendering like
Yeah.
not so much realistic scenery, but
I was going to say I was an AutoCAD power user in the long ago, far away, back when computers were beige times. Um, uh, and I know with AutoCAD there was a really steep learning curve because it's kind of like Photoshop is today, where you open it up and you have literally 1,000 different buttons
yeah.
that just have like a picture or a graphic on them, and like unless like there's no real intuitive way to get started. And I'm thinking like stuff like Blender
It's also
is
kind
a
of in the
nice
same
way to
boat.
ease into it,
Yeah.
because that's a little bit more limited. But then like scale it back even further and go into like Tinkercad, where it's definitely more of a drag and drop situation. And I kind of think like that might be a nice progression for folks that are just getting started, is to start with like the free web-based stuff, just to, because you mentioned this earlier, that yes, it's a very, very broad category,
Hmm.
but the terminology crosses between all of them, right?
Yeah. It's more the
I,
specifics of what the computer's doing with the software as opposed to
yeah,
like what the software is.
what the commands are, right?
Yeah.
And I feel like there's a lot of crossover, even in terms of like the symbols that are used for the different tools and actions. There tends to be a strong overlap between even very different software, like but like they tend to kind of refer to each other in a way.
Yeah,
So
it's
that,
fair. It like understandably, like you'll run across a lot of tools that have the same names like offset, stuff like that, where like you're taking an object and just like expanding it a little further off from itself,
right,
or learning how to do specific,
masking.
yeah, stuff like that. A lot of that just kind of covers very broad general terms. They'll be used a lot and across all of these software. Um, but yeah, like you were saying, there is a general progression that you should probably follow if you wanted to get into them. Like I said, Tinkercad is very simplistic, uses a lot of primitives. You're going to be using your mouse and keyboard to kind of drag and drop shapes. You're going to be using the keyboard to define like the actual sizes of the shapes, stuff like that. Comparatively to Blender, you can drag and drop primitives onto there, but you can also kind of like click specific points on the actual object and kind of move it to where you want it to be to kind of sculpt the shape that you want, as opposed to just plopping it where you need it to be.
Yeah.
Um, and then once again, AutoCAD kind of goes far and away with everything, with how precise it can be. Once again, it's used for architecture and engineering, so you kind of need that precision, very, very exact, down to like the nth
Mm-hmm.
decimal. Um, when it comes to rendering, Blender might take AutoCAD. um, from my own experience, AutoCAD does a really good job of rendering 2D and 3D while you're working on it. But if you wanted to get like a specific render of something as a scene, it typically just compiles everything into like a raster image. And so it looks kind of muddy. It's 2D, kind of gives you like sunlight, trees, kind of stuff like that. But it conveys like what a building or an object might look in, you know, a scene.
Yeah, I
Visual.
would agree with that. It's definitely a lot better at the kind of the mesh view or the like blueprint
Mhm.
type views. Whereas some of the newer, especially some of the online ones like Blender, you can get a little bit prettier with it.
Yeah.
I'll say it that way. You can get prettier with it.
Textures
Whereas
are
the
very
AutoCAD, you
quality
can get
there.
very technical term. Very
Yes.
I use it with my thingamabob and my Watsits.
So like texturing would be like an image that's placed on top of like another image to kind of like wrap it to kind of give it, I guess depth would be a good way to describe it.
Yeah, texture, depth, all of that stuff.
Yeah.
Definitely. Um, Speaking of some of these, we are going to be going into a little bit of a dive with Tinkercad next month. So June 14th, another Wednesday, 6 o'clock, we're going to be playing with Tinkercad a little bit. So
Mhm.
it'll be similar to this program where we're not going to go super in depth on the nitty gritty of it, but just to give you an idea of how to first get set up in it, how to first get a project started in it, and
Mhm.
kind of give you the basics of maybe creating that first design for yourself in there. So that'll be coming up here on June 14th. All right, I saw a couple of folks typing, and I think they got shy, or maybe we answered their question, which would be even better. So we'll give it another minute here in case anybody has any last minute questions. If you do think of a question after the program, you're like, oh, that's right, I meant to ask. Like we said, just reach out to us, hcplc.org/contact. That page has our phone number and all of our various contact information on it, including our super fun Ask a Librarian tool. So if you, like me, would rather do your taxes than pick up a phone and call someone and talk to them on an actual telephone, try the Ask a Librarian. That's one of us, Hillsborough County librarians is going to be there answering that. Chat, text, email, text-based, how we like to do. So if you
Mhm.
don't want to talk to someone on the phone, I feel you. Hit that Ask a Librarian button on our contact page. They're going to be able to point you to the same resources that we linked to today. They'll be able to follow up and get your message to us if you have something specific about this program. So don't hesitate to reach out that way, and they will get you set up with the right information. Or, of course, stop into your local branch, and especially the ones that have a hive.
Mhm.
Especially if your local branch has a hive set up, they're going to have somebody there that knows some stuff about this. So check that out. Have them point you in the right direction. We love to see it. We love to help. If you want more tech topics, hcplc.org/tech topics. That kind of has an overview of all these programs, and it includes a link to our YouTube channel. So all of our stuff, we record it, we'll post it on our YouTube channel, usually within a week or two of the program. So if you want to catch up, if you joined us a little bit later, you want to catch up on maybe what you missed during the first few minutes, just catch up with the recording afterwards. It'll be there soon. And yeah, keep an eye out on the calendar for summer reading programs. Those are hitting your branch very, very soon. So they are starting to pop up on the event calendar. So also check those out. A lot of fun maker activities in your branches for summer. Andre, thank you so much for putting this program together. I know it's so hard to have a broad topic like this and have a short 20-minute program on it. And you did a great job. It was a lot of fun and yeah, very exciting. Thanks, Andre.
Yeah, no problem. Thanks for having me,
All
Lisa.
right, folks. We will see you next time. Hopefully we'll have you join us again in June for our Tinkercad program, and we'll see you next time. Bye, folks.
See ya.